Welcome students to my Java classes. In this video we are going to discuss about the basic concept from where the programming and establishing logic begins, and it is flow of control. Now, what is flow of control? Before we start discussing what is flow of control, let us try to understand what is a control. Now, in a program, if there are multiple statements, one by one, the lines of code are going to get executed. Now, when line 1 gets executed, at that moment, line 1's instructions are going to control the entire computer system. Or in other words, we can say the processor marks the statement number 1 and then performs the operation as instructed in statement number 1. So in simple words, we can say that at that moment, statement number 1 of the program controls the entire computer system. So if there are multiple statements, then after line 1, when line 2 will get executed, we can say that the control from line 1 shifts to the line 2. Now, what is flow of control? Flow of control is the order in which the statements or lines of codes, which is also known as LOCs, execute one after another. Say in a program, if there are 10 statements or LOCs, then they will execute top to down. But if the flow of control is manipulated, they might show a variation in the movement. Now, we are going to discuss all different types of flow of controls. And the basic types of flow of controls which we are going to discuss in this video is sequence, selection, iteration using loops. Some of us might call it iteration using loops. Both are correct, just the differences in the pronunciation. Now, for us, meaning is the same. Now, next, what we are going to discuss in this video basically is a brief about sequence and selection, plus few sample programs which we can represent in sequence and selection. We will not cover the entire thing because the entire topic, flow of control, is a vast topic which better is not to conclude in one single video. We are going to make multiple videos on the same topic, and we are going to keep every video light enough so that you enjoy it. Now, I'll move to the first type of flow of control, which is sequence. Now, what is a sequence? Sequence is a flow of control where we don't find any deviation. It strictly follows top to down approach. That means when in a program no additional control structure is used. That means you are not using any selection or not using any loop. Then in that case, the flow of control flows strictly top to down without any deviation. In that case, the program is known to have a sequential structure. Let us refer to the flowchart where we are finding that we are taking two numbers and then we are adding them and the sum is getting displayed. Now in this flowchart, you can see the first input box here states that we are going to read the value of A and B. After we read the value of A and B, we are going to the next step where A and B are going to be added and the sum is going to be stored in sum, and then the third statement which says to display the sum. So as a whole, we can see here that three basic steps are involved here, and the flow of control goes top to down. That means 1, then 2, then 3, and then it ends. So sequence is those type of programs where we are not using any type of selection or any type of iteration. It goes simply top to down. Now let us discuss the next type of flow of control, and it is selection. Now what happens in selection? When in a program, control structure is used to establish multiple paths for the flow of control to pass, and only one among those pathways is taken. In that case, the program is known to have a selection structure. Now, let us consider this flowchart, and this flowchart is to take two numbers and display the larger value. Now in this case, if you see, the first statement is to take the inputs A and B, and then the second one, which is going to decide which statement to execute out of 3A and 3B. Here it is stated that if the value of A is smaller than B, in that case the value of B is going to be printed. That means if it is smaller, B is larger. Now if B is larger, B will be printed. And otherwise, in other case, if it is not smaller, say if A is greater or it is equal, in both the cases it is going to show the value of A. Now logically it might be incorrect, because if the value of A and B, say I am working with values, it's going to be helpful to you. Now say the value of A is 5, B is 7. Now 5 is less than 7, so in that case the value of B, which is 7, 7 is going to be printed. So out of 5 and 7, 7 is larger value. Now in next case, let us consider the value of A is 7 and B is 5. Now in that case, what we are going to find? Is 7 less than 5? No. So in that case, value of A, which is 7, is going to be printed. So what is basically going to happen here? The basic thing which is going to happen here is, out of A and B, whichever is larger, that is going to get printed. But while it's going to be printed, there is one thing which we are going to miss. That is the third possibility. The third possibility is, if A is not larger or B is not larger, in that case the third possibility lies where both are equal. Now in that case, what is going to happen? Now if the value of A and B both are 5, then is 5 less than 5? No. So it is going to show the larger value is 5. But out of 5 and 5, the larger value is not 5. But in our program, we have taken the logic like this. So this is the inadequacy of the logic of the flowchart here. So in those cases, if you want to trap those cases and if you want to figure out those solutions, you cannot limit it with this type of structure. And so we are going to discuss many different types and many different ways in selection can be established. But here to understand it, say for example, if out of A and B, the larger value, and if they are same, then also the value is going to be printed. It is not going to say whether A is larger or B is larger. Alright, it is going to just print the value of that larger variable. Now in that case, here when we were discussing about multiple pathways, we can see one pathway goes like 1, 2, and if 2 is saying yes, it goes through 3B and then terminates. So it is 1, 2 and then 3B and then terminates. Now if the statement, that is condition which is there in statement number 2, is not satisfying, in that case what we will see? We will see it runs like 1, 2 and then 3A. Here you can see 1, 2 and if it is no, it goes to 3A. So this is how we can see a selection structure. You will always find that multiple pathways are going to be there, but only one of the pathways will get executed. So when there are varieties of types in selection, let us now see what all basic types we actually find in Java. In other words, what all basic types of control structure Java allows us to use. Now we can see here there are 6 different types of selection structure. If else, else, which is also known as nested if else, switch case, and then nested switch case, and then at the end it is ternary or conditional operator. In this video we are going to discuss about the first 3, and rest 3 we are going to discuss in the next video, and upcoming videos are going to cover iteration using loops. Now if we understand flow of control completely, then the basics of programming or establishing your logic becomes very easy and it completely comes under your grip. Now let us see a sample program where we are going to print output which is going to be conditional. Conditional in the sense, if a condition satisfies, a certain output is going to be printed, and otherwise nothing is going to be printed in that place. Now I'm taking you to the situation. Now the situation is, we have to write a program where we are going to accept marks of two subjects, and then we have to display the average marks along with a congratulating message only if the average is above 90. Now in this case, you can see there are 5 basic steps. Now out of these 5 basic steps, the first 4 are going to be obviously running. Like the input of A and B will be done, average is going to be calculated, the average will be displayed, because up to this is going to be running in a standard form. After that, it's going to check whether the average which is computed is more than 90 or not. Here you can see statement number 4, average, if it is greater than 90, if it is yes, then it is showing you a congratulating message. Whereas if it is no, it is not doing anything, it is just coming out and then closing the program. It is terminating the program. So now if you see multiple pathways, we can see there are 2 multiple pathways. Now one goes from 1 to 4, and then if the condition says no, it terminates the program, and another goes 1 to 4, and if the condition is yes, it goes to the 5th statement, and then it prints the congratulating message. Now let us see how this program executes in the IDE. I will take you to the IDE now. The IDE, till here we have accepted the value of A and B, that means marks of first subject and the second subject, and then we have calculated the average. Now here you can see average is equals to A plus B divided by 2.0. Now there is a great need of 2.0. I will explain it in my upcoming videos, but for now, if you write divided by 2, you will get a result which is going to be different from what you now will find by writing divided by 2.0. Then after calculating the average, it is printing the value of average. Now this is irrespective of the value of average, even if it is less than 90 or it is greater than 90, in both the cases it is going to print this average. Now if the average is 90, only in that case this is going to get executed. So how we are writing it? We are writing the keyword if, and within parenthesis we are going to write the condition. Always remember, whenever we are writing a Java code, the condition should be kept within a set of parentheses, and then it is going to be prefixed by the keyword if. Now in this case, how many statements are going to get executed if this condition is true? It is just 1. Now if it is just 1, then you can write it exactly the way you can see it here. But if there are multiple statements, then I definitely need to put it within a block of curly braces. Now this block of curly brace will denote that there are multiple statements, but all multiple statements are going to be considered in one single block. So if the condition is satisfying, then the block needs to get executed. It is not just the single statement, it is all the lines which are there inside it. But here, as I said, that we don't need to put a curly brace. Why? Because it is just a single line of code. So even if I remove it, it is not going to make any difference. I'm removing it, I'm compiling it. Just like the previous time, it is shown no syntax error. I'm going to run it. So in the first occurrence, I'll be running it with a value which is going to give me the average more than 90. So I will expect that it should show me average plus it should congratulate me. So as per expectation, it has shown me both the things. Now I will run it in a way where I'll be getting average below 90 or exactly 90. So if it is 89 and then 91, so it is going to be exactly 90, which is not greater than it. So it will just show the average without congratulating me. So that's how this program actually runs. Now in this, we have seen that if this condition is not satisfying, then what to do? Nothing is defined, so we are ending it here. So in those cases where it is clear that when the condition satisfies, what to do, but it is not at all stated that what should get printed or executed if the condition is not true. All those cases we are going to use if, and where we need to have both the branches, like if it is yes, if condition is true, then also we know what to do, and if it is not true, then also we know what to do. Like both are two different branches and one executes, the other gets skipped, and the other executes, the other one gets skipped. In that case, we will not be able to use only if, we will have to use if and else. I'll be showing you in the next slide. Now I'm taking you to the next slide where we can see the usage or a sample program implementing if and else. Now in this program, we are going to read two numbers and display the larger value. This is the same program which I have taken while we were discussing the basic structure of selection. So what we can see, if I remind you, A and B we have taken, we have printed whichever was the larger value. Now I am coming to it. In this case, I have written the program just the same way what I have seen in the previous slide, but one thing is extra, that is else is extra. Now in this part here, else talks about what will happen or what should be done if this is not satisfying. If the condition is not satisfying, in that case, whatever is there following the else statement gets executed. Now I will take you to the program. Now in the program we can see the code is there. So in this case, up to this we are reading the first two numbers. Here we are comparing it, and then we are printing if this is satisfying, the larger number here, that is B, and if this is not satisfying, then the larger number as A. Now as I was telling you that we don't require curly brace if only one statement is there. So if this condition is true, then only one statement needs to get executed. So I don't require curly brace. I will show you other cases where we will have multiple statements to execute. So in those cases we will definitely take a set of curly brace. Now let us see how it runs. I am giving a smaller value first, then in this case the second value is larger, so it is going to show me the larger number is 15. Now next I am going to run it once more, keeping the larger number first and then the smaller number, so it is going to print me both the ways. Now what will happen if both are equal? Then it is showing me the number is 5. Now in this case we have a limitation in our program logic, because we have not covered what should happen if they are equal. So we have only covered two states, like if A is greater, print A, if B is greater, print B. But we are not talking about what will happen if both are equal. So in case we need to have three different outputs or three different pathways, we cannot have a single condition. There we'll have to join or branch conditions one after another. That is known as nested if else. So So we are going to discuss nested if else in the next slide. So let us go to the next slide. The next slide talks about to take an integer and then check whether it is positive, negative or it is 0. That means it is now going to cover all three possibilities. Now if it is all three possibilities, we definitely require multiple conditions, because one condition can give you maximum 2 branches. So what is now going to happen here is, if you see, the statement number 1 is all about reading the value of a. Now statement number 2 says it is greater or not. Now say for example, if the number which user has supplied is 50, 50. Now is 50 greater than 0? Yes. Now if it is yes, it is going to go to 3b and will print positive, and then will terminate. Now say user has this time given minus 48. So minus 48. We are going to come to this condition once again. Now will it be yes? Is minus 48 greater than 0? No. Now see, this condition had only 2 branches. One is towards yes, another is towards no. Now in this case, when we are coming towards no, we are meeting another condition here. Now with minus 48 we came to no, and now is minus 48 less than 0? Yes. So we are going towards this direction and we are printing negative, and then we are coming out here. Now if it is exactly 0, this time if it is 0, is 0 greater than 0? No. It's going to meet this next condition. Is 0 less than 0? No. Then it's going to go to print 0, and then it is going to end subsequently. So here what we have seen? We have seen that one if else block like 3a, 3a2 and 3a1, this is one if else block, is attached to the block 2, 3b, 3a. So now we can say that we have put one if else inside another if else. So we, for this reason, call it nested if else. And here you can see there are 3 pathways also we can notice. One is 1, 2, and if 2 says yes, we go to 3b and then terminate. And here 1, 2, if 2 says no, we go to 3a. Now from 3a there are 2 more branches coming out. Either it is yes, and if it is yes, it goes to 3a1, and if it is no, we go to 1, 2, no, then 3a, again no, then it is 3a2. So let us see how the code executes. I'm going to take you to the IDE. This is the code for it. So here what is happening? Up to this we are reading the input. Now here we are checking whether the value of a is greater than 0 or not, and if it is greater than 0, we are printing positive. If it is less than 0, in that case we are printing negative, and if it is neither positive nor negative, then in that case it is 0. So what is happening when we are writing it? We are writing it up to this. If you notice, if this satisfies, this needs to be executed, and if this does not satisfy, it goes to else. Now after going to else, what it means? It means if once again. Now this is another block. Now here, if this satisfies, then immediately next line is going to get executed, and if this does not satisfy, then in that case it has to execute the final else. So in this way we can have as many nesting we require. Now I'm going to show you another example where we will be finding more such chains, but not in this video. For that you will have to wait for the next video. Please subscribe my channel and then hit the bell icon, and like whenever I will be putting up any video, you will get to know about it. And please do practice programs, because coding increases your logical ability. With that, your skill of learning new things also develop fast. So that's all for this video. We are going to have the next topics covered in the upcoming videos. Happy coding. Thank you.